of integration that a person learns. And then Calc 2 expands on this greatly and gives you a whole other slew of techniques, a whole chapter of techniques, or maybe even a little bit more than that. In your second semester. So the idea is this. Let's start with the example number 17 from the textbook. Where we need to find the indefinite integral, which means find an antiderivative of 2x times x squared minus 1 to the 99th power. So obviously that 99th power is there for effect, right? It's there to illustrate what would you do without u substitution. Well, if you didn't have u substitution, then right now what you would do is you would multiply x squared minus 1 times itself 99 times until you had a, I guess x squared, so you had a 191st degree polynomial, right? 192 terms. You multiply by 2x, so now it's 192nd degree polynomial, but still has 191 terms or whatever I just said. So that would be very cumbersome if you had to do that. So the idea is to avoid that. So what you're going to do is you're going to make a substitution. You're going to use the letter u for tradition's sake. So u is going to equal something. So now, what does u need to equal in this problem?
X squared.
That's right. Very good. X squared minus 1. Now, this technique only works if, once you decide what u is going to be in your substitution, this would greatly simplify the problem. Instead of being x squared minus 1 to the 99th, it would be u to the 99th. I'll use a simple power rule on it, right? I'll raise the power up to 100, I'll divide by 100, and I'll have an expression there. The 2x is causing a problem, though, with that. Okay? So what has to happen is that whatever u is for your substitution, if it's x squared minus 1, you need to make sure that when you take the derivative, du dx, you must get the other part of your integrand, right? That must appear in the integrand. Now, there are a couple caveats to that. One is, the constant is absolutely irrelevant. You can always finagle any multiple constant, right? So the fact that this were to be 2x is perfect, but if it wasn't, it was just x, or if it was 10x, we would still be fine, right? We'll still work through the problem, no big deal. Okay? I'm sure we'll see some. So now, once you have the derivative of your substitution with respect to x, then you'll write du equals 2x, and you're going to multiply over to the other side dx in a sense. Okay? So, and I'm just going to write it like this for now. I'm not going to use this little intermediate step to write the derivative, because I know I'm always going to put dx on the other side. Okay? So it's always going to be. So now we have two expressions. One, our substitution, and second, an implication from our substitution. Right? And the change of u is related to the change of x somehow, now that I've written them in this form, that u is a function of x. So now I replace the material in here with these two substitutions. So we have the integral now, x squared minus 1 to the 99th is now u to the 99th, and 2x dx is proper now to think of this as being 2x times dx sitting here, right? That this is like three things multiplied together. The dx is a little multiple on the end, okay? So since it's since these are all factors, it doesn't matter the order of that I put the factors in. So I can imagine that x squared minus 1 to the 99th is over here, and 2x dx is on the end here. Okay? So the 2x dx becomes du. So now my integrand is in u, and the differential in the end is in u. So this is a standard integral now. Right? Okay. So I already mentioned what this antiderivative is. It is 1 over 100 u to the 100th plus an arbitrary constant. Since it is an indefinite integral, we're just finding an antiderivative. We're not using the fundamental theorem per se. And now we need to change it back to x. So resubstitute, u is x squared minus 1. So I have 1 over 100 x squared minus 1 to the 100th plus c. There is our answer. There's our antiderivative.
What happened to the du?
What happened to the du?
Yeah.
Remember, just like before, if I had done this, if it's just telling you what variable you're integrating with respect to. That's all it's doing. Okay, so there's our antiderivative. Any questions about the first u substitution? They do have some subtleties to them sometimes. So make sure this one's clear.
Wait, can you show us an example where the constant is in between?
Okay.
That's the antiderivative?
Yeah. You can differentiate your head real fast. Think about it. If you brought down 100, that cancels. You now have x squared minus 1 to the 99th. But you got to do chain rule. Chain rule on the inside is going to give you 2x. So 2x, x squared minus 1 to the 99th. Perfect. C, of course, is destroyed in that process. I would do that in general. If you're not totally solid on U substitution, just check. You know how to differentiate fast, you know how to integrate, probably. So differentiate it and make sure you do get the integrand back. And if not, you need to do something else. Right? You can adjust it or start the problem over. All right, number 19. This is certainly meat and potato. I mean, you don't go into Calc 2 not knowing how to do U substitution. That would be a horrible mistake.
Only one more for me.
I said another mistake for you. There's that.
One more math class for me.
Well, go. Make sure you go in knowing.
I don't need
Are
Calc 2.
you talking about Calc 1 repeated again? That's the next math class, or?
No,
Oh.
statistics.
I'm just messing with you. Statistics. I feel sorry for you. Oh, what a boring class.
Is it?
Is this
Number 19.
harder than calculus?
It's just different.
No.
It's just a different beast.
It's a different
It's
subject.
annoying.
It's a bunch of words, okay? That's all it is.
Bunch of word problems, and you're using scatter plots and stuff.
It's just
It's
annoying.
different. It's like
It's a whole different math.
Obviously, statistics is really calculus based, but not the one you're going to take probably, right? If you take a higher level statistics course, it's all based on calculus. But the statistics course you usually take, like a sophomore level 200 class, is very formulaic. Remember these formulas, apply them when necessary, call it a day. That's kind of how it runs. But you do have to be able to read the question and know what to apply, that's true. But it's not rigorous in the mathematical sense. So we have 2x squared above, and below you have the root, number 19, of 1 minus 4x cubed. Yeah, 1 minus 4x cubed. Same thing, find the antiderivative of this expression, or an antiderivative. So that means you got the plus c on the end is the important thing about that, the way they're phrasing it, an antiderivative. Okay, so what do you want to make the substitution? U equals what?
1 minus 4x
cubed.
Sounds reasonable.
Isn't it always the trick about it? You're always supposed to pick the most complex part of the equation.
Interesting you say that. It's not, it has to do that in a sense. It's more about composition, okay? Because what U substitution is really doing, I mentioned it before, but now that we're actually on it, you hopefully remember it now, it is undoing chain rule. U substitution undoes a chain rule result. And chain rule is based on what? Compositions, right? So therefore, usually the inner function within the integrand is going to be a good candidate, right? But it doesn't, remember these problems are trumped up, right? If this was 2x to the first right now, what are you going to do? You're going to start crying, okay? Why? Because if you let u be 1 minus 4x cubed, which seems reasonable at first, when you take du, what are you going to get? Negative 12x squared dx. Crud, that's not a square, and that is. So your substitution is now worthless. Okay? So they're making these problems work out perfectly. Since this is a square up here, letting u equal 1 minus 4x cubed does work, right? I see I have an x squared here, and an x squared here, and I told you these little constant multiples we can always handle. That's not a big deal. Okay? So how do you handle them? This was Razak's question. What are you going to do with this now? Well, what I'd really like to have is this to read 2x squared dx. This is the way I approach it. There are many ways to look at this problem. But I want the right-hand side of the du to equal 2x squared dx, because that's what I have right here, right? That's the leftover material I have. Upon replacing this with u, I would have